In this video, we're going to go over various caching systems, and by the end of this video, you're going to be able to understand the difference between various caching systems and choose whichever one is more beneficial for your website. My name is Anton. Let's learn something new. Let's say you're a developer who just created a website, or maybe you're a large company that sells products online, or maybe you're a small business that created a landing page to attract new customers. What do all of these people have in common? Right, a website. According to various research conducted by major companies such as Google, Cloudflare, Pinterest, and others, it has been determined that the speed of your website dramatically impacts your site's SEO, and thus directly affects how your users perceive you as a brand. There's nothing worse losing a potential customer just because they had to wait an extra second for your site to load. According to Pinterest, once they reduced perceived wait times by 40%, it increased the search engine traffic and signups by 15%. In another research conducted by BBC, it was determined that for every additional second their site took to load, BBC lost an additional 10% of the users. For Mobify, every 100 millisecond decrease in homepage load speed worked out to a 1.11 increase in session-based conversion, yielding an average annual revenue increase of nearly $380,000. Additionally, a 100 millisecond decrease in checkout page load speed amounted to a 1.55% increase in session-based conversion, which in turn yielded an average annual revenue increase of nearly $530,000. One of the biggest performance gains you can have on your website is by enabling caching. But there are so many caching systems out there: browser caching, page caching, object caching. How do you know which one is right for your website? It might seem impossible to understand all of this without the help of a professional developer. Fear not, my friend, I have you covered. What is actually cache and how does it work? Cache is a hardware or software component that stores data so that future requests for that data can be served faster. If we look at how users access websites, a simplified version of a request would look something like this. A user types in the website address inside the browser on a computer. That request is then forwarded to the physical web server that processes the request. The web server is then going to forward that request to PHP, which will perform all the required queries to the database, process the resulting data, and generate an HTML page that will be sent back to the user. The generated web page consists of a mix of HTML with links to images, JavaScript, and CSS files. All these assets are called static assets, because the web server does not change them. So once the browser receives an HTML page in the response, it will make consecutive requests to fetch all those static assets. This is true for every single user that wants to access a website. But every time a page is refreshed on the browser, this whole process happens all over again, and it takes precious time and bandwidth to fetch everything again. To improve the load time of pages, each browser has its own caching system in place, and this system is called browser caching. Browser caching will store all the static assets, images, JavaScript, and CSS files on the user's computer. The next time a user visits any website, if the browser has any static assets cached, those files will be loaded directly from the user's computer instead of doing lengthy requests to the web server. Browser cache settings are controlled on the web server via expiry headers that are appended to each asset in the response. Important thing to remember is, let WordPress handle asset management. Never add changes directly to your site's CSS or JavaScript files, or replace images without renaming them, because this will lead to users contacting support and support saying, "Have you tried clearing your browser cache?" Key takeaway: browser caching stores static assets on the user's computer to significantly improve the page load time. You should never have this option disabled. We've covered the user side of things, but what about the web server side? Whenever someone opens a page, the server will generate the HTML content, and it's going to be exactly the same for everyone. But each request will still use up resources, and if your hardware can't handle all the incoming requests, that's when you start experiencing performance problems, which result in slower response time. To avoid unnecessary processing on the web server, we have page caching. Page caching will store a copy of the generated HTML page and serve it to the users on all the consecutive requests for that specific web page. And WordPress actually has a special mechanism that makes all this work. When installing any caching plugin on a website and enabling page caching, the plugin will create a file called advancedcache.php, and whenever that file is present inside the WP contents directory, WordPress knows that instead of loading up the core engine and doing all the processing, the request should be first forwarded to the caching plugin to see if it can find the cached page. If a cached page is found, the web server will then send that page back to the browser, avoiding the costly WordPress processing. If not, the request is then forwarded to the WordPress backend, it is fully processed, a new HTML page is generated, it's stored in page cache and forwarded back to the user. But what happens if a page cannot be cached? For example, a product checkout page, or a page that contains specific user private data. Does it mean we can't optimize processing? Well, we can. We have object caching. Object caching will store the results of database requests, so the next time someone needs to visit a page that is not cached, we avoid all database processing. The most common object caching software is Redis and Memcached. And again, WordPress comes with out-of-the-box support for object caching. All you need is a server, for example a Redis server, a Redis plugin, and you're set. But wait, there's even more. Introducing server-side caching. Server-side caching is a mechanism that avoids PHP processing altogether. As the name implies, it's caching that's handled by the server. So instead of using PHP to process the request, the web server is actually going to try to find the cached page and serve it back to the user. An example of server-side caching is FastCGI caching module in Nginx. The benefits of server-side caching is that it's super fast and it allows your server to handle thousands of requests per second with only a limited amount of resources. However, the downside is because we're not using PHP, sometimes it gets a bit harder to control the cache. So most likely you'll need to set up special exclusion rules, you'll need to find a way to purge cache, and all that stuff. Personally, I try to stay away from server-side caching because the performance difference for a single request between server-side caching and page caching is very minimal. There's one cache system that's left. Let's say your website is hosted in the United States, and the majority of your clients are US-based. Most likely, the requests won't take much time because all the users are near the data center. But let's say you had a user from Russia. It's a long way from your hosting provider, and the request alone will take 300 to 400 milliseconds just to travel that distance. To tackle this issue, we have CDN and EDGE cache. Both CDN and EDGE cache are usually offered by a third-party provider throughout their network of servers that are located around the world. These servers will act as a proxy between the user and your website. For example, if a user from Russia wants to access a website hosted in the United States, instead of sending all the requests to the United States data center, they would send the request to the proxy location, probably somewhere in Europe. That page will be served from the CDN location closest to the user. The difference between CDN and EDGE caching is that CDN handles static assets, images, JavaScript and CSS files, and EDGE caching handles the actual HTML page. There are multiple CDN providers out there. Do your research before you choose one. Personally, I'm a big fan of Cloudflare because they offer both CDN for your static assets and they have a service called Automatic Platform Optimization for WordPress, which basically acts as the EDGE caching system for your WordPress website. That's it for this video. If you want to know more about caching, a few years ago I was a guest speaker on a podcast that talked about caching. I'll leave a link down in the description below. If this video helped you out, please leave a like to the video. If you have any questions, post them down in the comments below, subscribe, and see you in the next video. Bye!